Hi, I'm Phil Kithill, CEO of Ocean-Based Climate Solutions. So I'd like to describe our wave-driven upwelling pump to you. It's actually quite simple. And as you can see on the left picture, there is a buoy, which is riding up and down on the waves. There's the surface water. About 15 meters below that, attached by a heavy weight rope, is the upwelling outlet. It's basically a box, a rectangle. I'll show you the detailed drawings. And then there's a funnel section which connects the circular round tube, fabric tube, to that outwelling. And we have to have that to match up the surface area of the tube compared to the rectangle. And then the 1.9 meter diameter fabric tube extends down 500 meters to the valve inlet and bottom weight. The bottom weight keeps it vertical in the ocean. So what we're doing with this simple wave-powered device, on each wave upslope, the entire rig rises. That closes the valve in the bottom and forces the water that's inside the tube upward by about the amount of the wave height. If it's a 2 meter wave, you get 2 meters of upward movement initially. And over successive waves, you're moving that water column upward. You're bringing up nutrients, which reach the sunlit upper ocean, and that triggers blooms of phytoplankton, microscopic algae, which absorb CO2. And when they die or are eaten, that CO2 is embodied in them and it sinks down below 500 meters and even deeper to the bottom of the ocean. And so here's a picture of a half-scale unit from a couple years ago, just to give you the flavor. And I'll go through the design drawings right now so you have a better idea of how it works. And so the buoy looks like this, and the key design feature is the fabric tube allows us to spool that up around the buoy and form a very compact unit. And we connect the bottom weight to it. And then to deploy it, we just drop it off the back of the boat. Well, the bottom weight is heavy and it sinks, and it's going to unspool the fabric, making the buoy rotate as it unspools. And so that fills the tube with water, so you're priming the tube and also unwinding the fabric. And that's how you get a 500-meter long tube into the water vertically. You cannot imagine how difficult that would be if it was a steel rigid or plastic rigid tube, 1.9 meters diameter. With a fabric tube and this way of doing it, it's how to do it, so it works. There are a couple of features on the buoy and on the bottom weight to slow that as it sinks, because we don't want it to go too fast. So there's some paddle wheels on the buoy to resist the spinning of the as it sinks. And then there's some flaps on the bottom weight, which also slow down its sinking rate. Here's another detailed drawing, which shows the tube and the funnel connecting the bottom weight where the valves are to the outlet where the water comes out 15 meters deep below the surface, and the heavyweight ropes that connect to the buoy itself. Now, another interesting and great feature is that the buoy starts out as a cylinder. It's round. It has to be in order to wrap the tube around it. But once it's fully deployed, the side wings come out and it forms a what we call a raft shape. And so it is a more rectangular instead of a cylinder. And that's more efficient for riding up and down the waves because there's more resistance, the flotation is more effective, you get better matchup between the waves and the buoy riding up and down. And one final drawing showing you the upwelling flaps and the valve inside the bottom section. And so that's what keeps it vertical in the water, and the water is goes in at the bottom on the wave upslope. Goes in at the bottom on the wave downslope. The entire rig is sinking. That opens the valves, water enters the bottom and exits at the top. And then on the wave upslope, the valves close due to the water pressure inside the tube, and that replenishes. The whole water column moves upward, ratcheting that water upward where it comes out. So thank you very much. Please let me know your questions.